So welcome again. So this is our topology. Now I am showing the IP addresses on our all topology routers interfaces. So I am showing. So so this is our topology and all the configured IP addresses and interfaces are up and protocols are up. Now I am going to configure tunnel between PE1 and PE2 routers for branches below and below1 and another tunnel between PE3 and PE4 routers for communication between red and red1 branches. So first we will configure interior gateway protocol like OSPF between P1, P2, P3 and P4 routers and also PE provider edge routers, so that our ISP will be free core and communication between BGP done without BGP on ISPs. So I'm going to configure OSPF on P1, P2, P3 and P4 routers and also P1 and P2, P3 and P4 routers. So first we will configure on P1. Now I am going to configure BGP on branch routers and provider edge routers. So first we will configure on branch below for BGP autonomous system number 1, sorry, AS10. We will announce the network 1.1.1.1 mask 255, 255, 255, 255. Then we will configure on provider edge router 1, router BGP 1234, neighbor 1.1, 1.1, root AS10. So then we will go to branch below 1 and configure router BGP AS20, AS20 neighbor 2.2, root S, sorry, 134 and P2 router BGP 1234 neighbor 6.2.1 root S20. We have not announced the network, so we will announce the network. Network 2.2.2.2 mask. Now the adjacency is up. So after that we will configure the GRE tunnel between provider edge router 1 and provider edge router 2. So interface tunnel 0, IP address 0.1 0. Tunnel source edge our loopback interface 0 and tunnel destination edge 66.60.66. This is the tunnel destination edge provider edge router to loopback interface. So same will be configured on provider edge router 2. So interface tunnel 0, IP address 0.2 0 tunnel source 0. And tunnel destination will be provider edge router 1 loopback interface, that is 55.55.55.55. So I think our tunnel is up and fully loaded, so we can check. Show interface tunnel 0. Yes, our tunnel is up. So we will advertise in BGP. So router BGP 1234. So you will form the neighborship between PE1 and PE2 by a tunnel interface. So, so to remote AS 134. Next hop serve. Then we will go to BGP 124. So now we'll check the communication between our branches. Ping the branch blue interface 2.2.2.2 source loop pair 0. Yes, it is working now. Now I am going to configure tunnel between P3 and P4 routers. So first I will configure the tunnel on P3 and P4. So I am going to P3 interface tunnel 0 IP address tunnel source destination. So on P4 interface tunnel 0 address zero source destination. Do so interface tunnel 0. So now this tunnel is up. Now I'm going to configure BGP between branch P3 and P4 and branch red 1. So first I will configure on branch red. Router BGP 30 neighbor MPLS 134 network branch red 1 router BGP 50 neighbor 92.168. 4 dot 2, this 4 dot 2, 4 dot 2, remote is 1 2 3 4, network 4 dot 4 dot 4 dot 4, minus 255, 255, 255. So this is done. And P3 router BGP 134 neighbor 168.3.1 remote AS 30 neighbor, neighbor 10 10 2 remote AS 34. Next host self P4 PGP 4 neighbor 4 dot four dot 1 remote AS 40 1 remote AS 1 2 3 4 so now it's time to verify the configuration. Ping 4.4.4.4 source loop.0 1 2 3 this. Yes, our terminal is now working. So here I have configured GRE tunneling between our PE routers to provide connectivity between branch routers. But this is not a scalable idea, and this is not more secure than MPLS, and GRE tunneling is not fast than MPLS. So idea is that uh, we want a more scalable, more faster network. So we will have to use MPLS. So now, so next topic, I will upload the video over MPLS introduction. Thanks for watching.